Chapter 20 Industrial Machines. One invention engenders another or cooperates with another. None lives or stands or dies alone. So, in the humble but extensive art of broom making, men and women worked along through ages, binding with their hands the supple twigs of trees or bushes, or of corn, by thongs, or cords, or wire, upon the rudely formed collar of a hand-smoothed stick, until the modern lathe and hollow mandrel armed with cutters, the power-driven shuttle, and the sewing machine, were invented. The lathe and mandrel to hold the stick while it was cut was used before, but it was long within the century that a hollow mandrel was first invented, which was provided internally with cutting beveled knives, and into which the stick was placed, carried through longitudinally, and during its passage cut smooth and finished. As broom corn became the chief product from which brooms are made, it became desirable to have a machine, after the corn had been scraped of its seed, to size and prepare the stems in regular lengths for the various sizes of brooms, and accordingly, such a machine was invented. Then a machine was needed and invented to wind the corn brush with the cord or wire, and tie it in a round bunch, preparatory to flattening and sewing it. Then followed different forms of broom sewing machines. Among the pioneers was one which received the round bunch between two compressing jaws, and pressed it flat. While so held, a needle with its coarse thread was forced through the broom above the binding, and the cord twined around it. Then a shuttle, also carrying a stout thread, was thrown over the cord, the needle receded, and was then forced through the broom again under the binding cord. Thus, in conjunction with the shuttle, the stitches were formed alternately above and below the binding twine, the holding jaws being raised intermittently for that purpose. As each stitch was formed, the machine fed the broom along laterally and intermittently. By another ingenious device, the cord was tied and cut when the sewing was completed. It is only by such machines, which treat the entire article from the first to the last step, that the immense number of brooms now necessary to supply the market are made. True it is that at first labor was displaced. At one time 17 skilled workmen would manufacture 500 dozen brooms per week. They had reduced the force of earlier times by making larger quantities by better processes. Then, when the broom sewing machines and other inventions got fairly to work, 9 men would turn out 1,200 dozen brooms per week. Thus, while the force was reduced nearly 1/2, the quantity of product was more than doubled. But as the cost of labor decreased and the product increased, the product became more plentiful and cheaper, the demand and use became greater, more broom corn was raised, more broom factories started, and soon the temporary displacement of labor was succeeded by a permanent increase in manufacture and in laborers, an increase in their wages, and an improvement in their condition. Useful and extensive as is its use, the broom does not compare in variety and wide application to the brush. The human body, cloth, leather, metals, wood and grains, everything that needs rubbing, cleaning, painting and polishing, meets the acquaintance of the brush. Nearly 100 species of brushes might be enumerated, each having an especial construction for a particular use. Although the majority of brushes are still made by hand, yet a few most ingenious machines have been made which greatly facilitate and speed the operation, and many mechanical appliances have been invented in aid of handwork. These machines and appliances, together with those which cut, turn, bore, smooth, and polish the handles and backs, to which the brush part is secured, have greatly changed and improved the art of brush making during the last 50 years. The first machine which attracted general attention was invented by Oscar D. and E. C. Woodbury of New York, and patented in 1870. As in hand making and before subjected to the action of the machine, the bristles are sorted as to length and color. A brush back, bored with holes by a gang of bits, which holes do not extend, however, all the way through the back, is placed in the machine under a cone-jointed plunger, adapted to enter the hole in the brush back. A comb-shaped slitted plate in the machine has then each slit filled with bristles, sufficient in number to form a single tuft. When the machine is started, the bristles in a slit are forced out therefrom through a twisted guideway, which forms them into a round tuft, and which is laid horizontally beneath a plunger, which, descending, first doubles the tuft, and as the plunger continues to descend, forces the double end down into the hole. The plunger is supplied with a wire from a reel, turns as it descends, and twists the wire around the lower end of the tuft, the wire being directed in that way by a spiral groove within the plunger. The continuing action of the plunger is such as to screw the wire into the back. The wire is cut when the rotary plunger commences its descent, and when the tuft is thus secured, the plunger ascends, the block is moved for another hole, and another set of bristles is presented for manipulation. Brushes with 70 holes can be turned out by this machine at the rate of 1 a minute. Another most ingenious machine for this purpose is that of Kennedy, Dis, and Cannon, patented in the United States in 1892. In this, brush blocks of varying sizes, but of the same pattern, are bored by the same machine which receives the bristles, and the tufts are inserted as fast as the holes are bored. Both machines are automatic in operation. Street sweeping machines began to appear about 1831 in England, shortly after in France, and then in cities in other countries. The simplest form and most effective sweeper comprises a large cylinder armed with spiral rows of splints and hung diagonally on the underside and across a frame having 2 or 4 wheels. This cylinder is connected by beveled gearing with the wheels, and in revolving throws the dirt from the street into a ridge on one side thereof, where it is swept into heaps by hand sweepers, and is then carted off. King of the United States was the inventor. A more recent improvement consists in the use of pneumatic means for removing the dust that is caused by the use of revolving brooms or brushes, such removal being effected by means of a hood that covers the area of the street beneath the body of the machine, and encloses an air exhaust, the sweepings being drawn through the exhaust mechanism, and deposited in a receptacle for the purpose, or in some instances deposited in a furnace carried by the machine and there burned. In cities having hard, smooth paved streets and sufficient municipal funds, the most effective, but most expensive way, has been found to keep a large force of men constantly at work with hoes, shovels, brooms, bags and carts, removing the dirt as fast as it accumulates. Abrading machines. One of the most striking inventions of the century is the application of the sandblast to industrial and artistic purposes. For ages the sands of the desert and wild mountain plains, lifted and driven by the whirling winds, had sheared and polished the edges and faces of rocks, and cut them into fantastic shapes, and the sands of the shore, tossed by the winds of the sea, had long scratched and bleared the windows of the fisherman's hut, before it occurred to the mind of man, that here were a force and an agent, which could be harnessed into his service. It was due finally to the inventive genius of B.F. Tilghman of Philadelphia, Pennsylvania, who, in 1870, patented a process by which common sand, powdered quartz, emery, or other comminuted sharp-cutting material, may be blown or driven with such force upon the surface of the hardest materials, as to cut, clean, engrave, and otherwise abrade them, in the most wonderful and satisfactory manner. Diamonds are abraded, glass polished, or engraved, or bored, metal castings cleaned, lithographic zinc plates grained, silverware frosted, stone and glass for jewelry shaped and figured, the inscriptions and ornaments of monuments and tombstones cut thereon, engravings and photographs copied, steel files cleaned and sharpened, and stones and marble carved into forms of beauty with more exactness, and in far less time, than by the chisel of the artisan. The gist of the process is the employment of a jet of sand or other hard abrading material, driven at a high velocity by a blast of air or steam, under a certain pressure, in accordance with the character of the work to be done. The sand is placed in a box-like receptacle into which the air or steam is forced, and the sand flowing into the same chamber is driven through a narrow slit or slice in the form of a thin sheet, directly onto the object to be abraded. By one method the surface of the object is first coated with tinfoil on which the artist traces his design, and this is then coated with melted transparent wax. Then when the wax is hardened it is cut away along the lines already indicated, and seen through the wax. The object now is subjected to the blast, and as the sand will not penetrate a softened material sufficient to abrade a surface beneath, the exposed portions alone will be cut away. The sand after it strikes is carried off by a blast to some receptacle, from which it is returned to its former place for further use. Other means may be used in the place of a slitted box, as a small or larger blowpipe, but the driving of the sand, or similar abrading material, with great force by the steam or air blast, is the essential feature of the process. Emery, that variety of the mineral corundum, consisting of crystalline alumina, resembling in appearance dark fine-grained iron ore, ranking next to the diamond in hardness, and a sister of the sapphire and the ruby, has long been used as an abradant. The Eastern nations have used corundum for this purpose for ages. Turkey and Greece once had a monopoly of it. Knight says, the corundum stone used by the Hindus and Chinese is composed of corundum powdered 2 parts, lac resin 1 part. The two are intimately mixed in an earthen vessel, kneaded and flattened, shaped and polished. A hole in the stone for the axis is made by a heated copper rod. However ancient the use of artificial stones for grinding and polishing, nevertheless it is true that a solid emery wheel in the form that has made it generally useful, in machines known as emery grinders, is a modern invention, and of American origin. In the manufacture of such machines, great attention and the highest scientific skill has been paid, first, to the material composing the wheel, and to the cementing substances by which the emery is compacted and bound in the strongest manner, to prevent bursting when driven at great speed. Secondly, to the construction of machines and wheels of a composition varying from the finest to the coarsest. And thirdly, to the proper balancing of the wheels and the machines, an operation of great nicety, in order that the wheel may be used on delicate tools, when driven at high speed, without producing uneven work, marking the objects, or endangering the breaking or bursting of the wheel. Such machines, when properly constructed, although not adapted to take the place of the file, other steel cutting tools, and the grindstone for many purposes, yet have very extensively displaced those tools for cutting edges, and the grinding and polishing of hardened metals, by reason, chiefly of their greater convenience, speed, and general adaptability. Not only tools of all sizes are ground and polished, but plowshares, stove and wrought iron plates, iron castings, the inner surfaces of hollow ironware, the bearings of spindles, arbors, and the surfaces of steel, chilled or cast iron rolls, etc. In the great class of industrial mechanics, no machines of the century have contributed more to the comfort and cleanliness of mankind than those by which wearing apparel in its vast quantities is washed and ironed more thoroughly, speedily, and satisfactorily in every way than is possible by the old hand systems. When it is remembered how under the old system such a large part of humanity, and this the weaker part, devoted such immense time and labor to the universal washing and ironing days, the invention of these machines and appliances must be regarded as among the great labor-saving blessings of the century. True, the individual washerwoman and washerman and ironers have by no means disappeared, and are still in evidence everywhere, yet the universal and general devotion of one half the human race to the wash-tub and ironing table for 2 or more days in the week is no longer necessary. And even for the individual worker, the convenient appliances and helps that have been invented have greatly relieved the occupation of pain and drudgery. Among modern devices in the laundry, worked by hand, is, first, the washing machine, in which the principle is adapted of rolling over or kneading the clothes. By moving a lever by hand up and down, the clothes are thoroughly rubbed, squeezed and lifted at each stroke. Then comes the wringer, a common form of which consists of 2 parallel rolls of vulcanized and otherwise specially treated rubber, fitted to shafts which, by an arrangement of cogwheels, gearing and springs in the framework at the ends of rolls, and a crank handle, are made to roll on each other. The clothes are passed between the rollers, the springs permit the rollers to yield, and part more or less, according to the thickness of the clothes. Then the old-fashioned, or the new-fashioned mangle is brought into play. The old-style mangle had a box, weighted with stone, which was reciprocated on rollers, and was run back and forth upon the clothes spread upon a polished table beneath. One of the more modern styles is on the principle of the wringer above described, or a series of rollers arranged around a central drum, and each having a rubber spring attached, by which means the clothes are not subjected to undue pressure at 1 or 2 points, as in the first mentioned kind. Starch is also applied by a similar machine. The cloth is dipped into a body of starch, or the same is applied by hand, and then the superfluous starch squeezed out as the clothes are passed through the rollers. But for hotels and other large institutions, washing is now done by steam power machinery. It is an attractive sight to step into a modern laundry, operated with the latest machinery on a largest scale. The first thing necessary in many localities is to clarify the water. This is done by attaching to the service pipe tanks filled with filtering material, through which the water flows before reaching the boiler. The driving engine and shafting are compactly placed at one end or side of the room, with boilers and kettles conveniently adjacent. The water and clothes are supplied to the washing machine, and operated by the engine. Steam may be used in addition to the engine to keep it boiling hot, or steam may be substituted entirely for the water. The machine may be one of several types selected especially for the particular class of goods to be washed. There is the dash wheel, constructed on the principle of the cylinder churn, the outer case being stationary and the revolving dash wheel watertight or perforated, which is the preferred form for collars and cuffs. In place of the dash wheel, cylinders are sometimes used, having from 60 to 70 revolutions a minute. Another form has vibrating arms or beaters, giving between 400 and 500 strokes a minute, and by which the clothes are squeezed between rubbing corrugated boards. The rubbing boards also roll the clothes over and over until they are thoroughly washed. In another form, a rotating cylinder for the clothes is provided with an arrangement of pipes by which either steam, water or bluing can be introduced as desired into the cylinder through its hollow journals, so that the clothes can be washed, rinsed and blued without removal from the machine. Another type has perforated reciprocating pistons, between which the clothes are alternately squeezed and released, a supply of fresh water being constantly introduced through one of the hollow cylinder journals, while the used water is discharged through the opposite journal, and in still another, the clothes are placed in a perforated cylinder within an outer casing, and propeller blades, assisted by other spiral blades, force a continuous current of water through the clothes. In ironing, hollow polishing rolls of various sizes are used, heated either by steam or gas. The articles to be ironed are placed in proper position upon a table and carried under and in contact with the rolls. Or the goods are ironed between a heated cylinder and a revolving drum covered with felting, and the polishing effected by the cylinder revolving faster than the drum. Ingenious forms of hand-operated ironing machines for turning over and ironing the edges of collars and other articles are in successful use.